Hello again. In this video, we will look at linearization, which is a method of writing physics equations in the form of a straight line. And then we will see how that helps us to determine other physical quantities. As per usual, I will use an example to demonstrate this concept. We will use Newton's second law. So let's look at this statement. So we want to conduct an experiment to verify Newton's second law when the net force is kept constant, and then we determine the magnitude of this net force. Newton's second law states that the acceleration is equal to F net divided by the mass, or acceleration directly proportional to the net force and is inversely proportional to the mass. So let's see now how we can use this process of rearranging this equation, and we write it in the form of a straight line equation, which is y is equal to mx plus c. Right. Before we do that, we will look at the graph of acceleration versus mass. So this is what we mean by saying that acceleration is inversely proportional to the mass. We get this graph, which is a curve. But then if we rearrange this equation to look like an equation of a straight line, we will have A is equal to F, and then we have brackets there, which is 1 over m. So now we have, if you take A as y, then F is the gradient m, and 1 over m is x, and c is 0 in this case. And then what do you get when you plot this A versus 1 over m? You get a straight line graph. Okay, so this is what we mean by linearization. And how is that going to help us? I'll show you that once we have this straight line graph here, we will be able to determine the physical quantity, which is the force. Okay, so let's do that with data. Let's start with this table here. Again, we have our independent variable as the mass, so we will increase the mass here. And then our dependent variable is the acceleration. You can see as the mass increases, the acceleration seems to be decreasing, and the controlled variable, the one that we keep constant, is the net force, and we aiming to determine its magnitude. Okay, so let's look at the graphs. So this would be your scatter plot here. So you will have this is the line of best fit. Let me just fix this line a bit there we go there. You would just draw the line of best fit for your data, and you can see that the acceleration decreases as the mass increases. So now let's look at how is that going to help us if we instead plot acceleration versus 1 over mass. So now this is our plot for acceleration versus 1 over mass, which is per kg, and you can see that as you plot these points, it's clear that the line of best fit here is a straight line. So then let's join that. Let's join the points. If we join the points, then this is our curve here, which is a nice straight line. And then the question we wanted to determine the net force. So we have this acceleration versus 1 over mass. It forms a straight line, and now we are able to determine the net force as follows. Right, so let me calculate the gradient here. So we'll have the gradient. The gradient is the change of the variable in the y-axis, which is in this case its acceleration, divided by the change of the variable in the x-axis, which is the variable 1 over m. And the units of acceleration, it's meters per square second, and the units of 1 over m is kilogram. So this is kilograms meters per square second, so which is Newton. Okay, so the gradient of this graph is going to give us the force. So I'm just going to select the points. I'm going to select the points. The mass is 0.5 and the acceleration is 3. So I'm going to have 3 minus, and then I'm going to select the point 0.4 and 2.4. So that is 3 minus 2.4 divided by, when the acceleration is 3, the mass is 0.5, and when the acceleration is 2.4, the mass is 0.4, right? And this gives us, so this is our gradient. But we've seen that the units of this gradient is newtons, so this is our force actually. So I'm just going to write F is equal to 0.6 divided by 0.1 newtons. So then F is equal to 6.0 newtons. So this is the magnitude of the force. So that's why we so this is useful when we write these equations in the linear form. We are able to determine these quantities using this method here, and you can look at the table. You can look at the table that if you multiply or this is acceleration, so by 1.5, so 1.5 times 4 is 0, and then it gives you 6.0 newtons, and then you can do that with any column, and then you get the same value there, right? And this is how your table would look like if you were to use F is MA, and then you will get this 6 there, and then if you add all these 6, because these values are pretty much the same in this case, so the average is just going to be the sum of these values divided by 5, and then get 6. So the force remains constant, and the value, fortunately, it doesn't with no deviation because of rounding. Right, so in the next video we'll look at the last part, which is extrapolation.